All right, let's talk about classifying matter. So, quick review of what we should already know about matter. Matter is anything that has mass and volume, and mass is simply the amount of matter in a substance or object. So, it's the amount of stuff that a substance or object has. Now, typically, we're going to measure that in milligrams, grams, or kilograms, but that will also depend on where you live. So if you are living in the United States, for example, you would measure in pounds and ounces. If you were living in Britain, you might measure in stone, right? Volume is the amount of space that a substance or object takes up, and that is measured in milliliters or liters typically, but again, that will differ depending on where you are. Most of the world is going to use milligrams, grams, and kilograms for mass, and they're going to use milliliters and liters for volume, but it will vary, right? Now, all matter has volume. So no matter how big or how small an object is, it will occupy some space. And when we think about large objects, that's fairly easy to visualize. But when we think about small objects, and I mean really, really, really small, it's a little harder to visualize. Now, if you were to take any object or any substance and break it down into smaller and smaller and smaller pieces, even those tiny little pieces are still going to have volume. Now, there are usually three states that matter will form. It's either going to be a solid, a liquid, or a gas, and you've learned about these before. Now, technically, there are a number of other states of matter, but the common ones, the ones that we typically see on Earth, are solid, liquid, and gas. There is also, for example, plasma that is not entirely uncommon. There are instances on Earth where we will see plasma exist, but it's not very common. And then there are a lot of other very, let's say, strange forms or states of matter that really only exist in very extreme experimental conditions. Now, matter can be changed from one state to another, and typically that is simply going to depend on temperature. So if you start at a very, very low temperature, and I'm talking really low, like what's referred to as absolute zero, so the very coldest possible temperature, everything is a solid at that temperature. And then as you slowly increase the temperature, things will start to melt. So different substances have different melting points, and so they will melt as you increase the temperature and go higher and higher and higher. And then once you hit around 0 degrees Celsius, that's where ice or water will melt, for example, and then you keep going higher and higher and higher, and then other solids will turn into liquids, some liquids will turn into gases. It all depends on what temperature you're at, all right? Now, typically, when we're talking about the three states of matter, we're usually talking about at room temperature, right? So at 20 degrees Celsius, a substance is usually either a solid, a liquid, or a gas, okay? Now, this is an image, or you've seen images similar to this before that you've seen before. So this indicates or shows the ways that matter can change states. So we can go from a solid to a liquid, and that's called melting or liquefaction. We can go from a liquid to a solid, and that's called freezing or solidification. We can go from a liquid to a gas, that's called evaporation, or we can go from a gas to a liquid, and that's called condensation. And these are pretty common, all right? These are changes of state that we usually see, and usually we associate that with water. So for example, we have snow here, so that's solid water. We've got liquid water here, and then we've got clouds or steam as gaseous water, all right? Now, another change of state that is significantly less common is going from solid to gas or gas to solid. And you'll notice it's called sublimation, regardless of which direction you're going. That is very, very uncommon. But one example you might be familiar with is dry ice. And what dry ice is that's simply solid, very cold carbon dioxide. And solid carbon dioxide will actually transition straight from a solid to a gas. It won't actually turn into a liquid first and then gas. It just goes straight to a gas. All right, so let's talk about these properties of states of matter. What do each one of these states look like? Well, we're going to look at solids, and in solids we have very small spaces between the particles. Remember, we've already talked about the particle theory, the idea that all substances are made up of tiny little particles, and those particles are constantly in motion, and so on and so on. So in a solid, the particles are very close together. In a liquid, there's a little bit more space in between them, and then finally in a gas, there's large spaces between them. So as far as the shape of a solid is typically going to have a definite shape. So if I were to take a chunk of plasticine, for example, and squish it into a weird shape, and then place it down on a table, it's going to hold that shape. Its volume is also going to stay definite. It's not going to get bigger or smaller as I just let it sit on the counter. A liquid, on the other hand, has a little bit more shape between it, or sorry, a little bit more space between its particles. So that means that its shape is not definite. If I were to take a glass of water and pour that on the counter, it's going to spread out. If I were to take it and put it into a different container, it's going to spread out and fill the bottom of that container. However, the amount of volume it has, the amount of space it takes up is not going to change. It's not going to get bigger or smaller. It's going to keep the same amount of space that it covers, but its shape will change. A gas, on the other hand, has no definite volume or shape. So a gas, if I were to hold it into a container and then pour it out onto the counter, is just going to spread out everywhere. And not only is it going to flatten out and take the shape of the container, so if I were to take it and pour it into another container, and to be clear, when I say gas, I mean as in not talking about gasoline. I'm not talking about gas for a car. I'm talking about a gas, something that has gaseous form. All right, so large spaces in between the particles, so something like air. So if I were to pour a gas like air from one container into another, it's going to take the shape of the container. But not only is it going to take the shape, it's actually going to spread out and fill the container. All right, so it will actually change its volume depending on the container it's in. So the particle theory of matter. This we've already looked at before. You've looked at it in previous years, but a summary. All matter is made up of extremely tiny particles. There are spaces between the particles. Each pure substance has its own kind of particle, different from the particles of other pure substances. Particles attract each other. Particles are always moving. And particles at a higher temperature move faster on average than particles at a lower temperature. Now, what we're going to focus on from here on in is looking at this point right here. Each pure substance has its own kind of particle, different from the particles of other pure substances. So the question is, how can we use that information to put matter into categories? Well, let's take a look at what those particles look like in relation to what we just talked about as far as the states of matter. So here is a solid, and we have all of our particles that are very close together, right? They're very tightly packed. When they are this close together, that means there are strong forces holding them together. In a liquid, we can see the particles are a little bit farther apart. They've spread out to fill up this container, and the forces between them is a little bit weaker. And then finally, in a gas, so in a balloon, for example, you can see the particles are quite far apart. The forces between those particles are rather weak. So in a solid, the amount of space between particles is very small. In a liquid, there's a little bit of space in between the particles, and then finally in gases, there's a large space. As far as the attraction goes between those particles, in a solid, there's a very strong attraction. In a liquid, there's some attraction, but not as much, and then in a gas, there's very little. And then as far as the motion of those particles goes, there's a very little motion in solids. In liquids, there's quite a bit, and in gas, there's a lot. They're able to move freely around each other.
Okay, Shiver.
Listen here, I'm totally together.
Oh my God.
Liquid.
All right, so we can actually use the particle theory to describe what happens to particles as they change state as well. So for example, if we're looking at a liquid turning into a gas, what happens to the space between the particles? Well, the space between the particles is going to get larger. Those particles are going to move farther apart. As far as the attraction, because they're moving farther apart from each other, the attraction gets weaker and the motion is going to increase. They are going to be able to move more freely. Okay. Now, notice something. When we have been talking about different states of matter and how or what happens when the particles or when the substances go from one state to another, the particles haven't changed. Right? It's just the relationship between the particles that has changed. So they're moving faster, or they're getting further apart, or they're moving closer together, or the attraction is getting stronger or weaker, but the particles themselves haven't changed what they are. Okay, that is important. So based on the particle theory, we can use in particle theory to classify matter. Right? So we can look at the very, very, very tiny particles that compose different substances and compare them to each other, and we can use that to put matter into different categories. So depending on which particles are present and how they are arranged, how they are associated with each other, what kind of relationship they have with each other, we can create different categories of matter. So different combinations are going to give different types of matter different properties. Now, here is a image or a diagram that we can use to kind of break down what all the classes or the categories of matter are. So we're going to start with matter, and then we're going to break it down into two major categories, and then we're going to break those categories down further. Okay, so the first breakdown. We can break matter down into what are called mixtures or pure substances. Now this is something that you may have actually seen before, but we're going to spend a little bit of time just to make sure that you're familiar with it. So a mixture will have variable composition, and that means that there will be different things in it. Okay, now those things, those different particles, can be separated by physical means. Now that could mean by something as simple as running it through a strainer. So we could have, rocks and sand and dirt in a mixture, and we could run it through a strainer, and the small particles would fall through and the large particles would be held behind. So that's one physical means of doing it. We can put a mixture into water, and some things will float, some things will fall. Okay, so there are a lot of different physical ways we can separate mixtures. And if we were to try to melt a mixture, different components of it will melt at different temperatures. Why? Because in a mixture, we have more than one kind of particle. And each particle is going to have its own chemical and physical properties. Remember, we learned about chemical and physical properties earlier. So one particle might have a melting point of 50 degrees Celsius, and another particle might have a melting point of 130 degrees Celsius, and another particle might have a melting point of 350 degrees Celsius. So by applying different temperatures to it, we can make different parts of it melt. So the melting point of the mixture is actually a range of a whole bunch of different temperatures because there are a whole bunch of different particles in it. Now with a pure substance, it will have a constant composition. So no matter where you look in the substance, no matter where you look in the object, it will look and be composed of the same thing. So for example, in a glass of water, no matter where you look in the glass of water, all you're going to find are water particles. All right, so it's not a mixture, it's just pure water. You cannot separate it into different smaller particles by physical means. So if you were to have, again, a glass of water, you cannot break those water particles apart simply by running it through a sieve or by heating it up or cooling it down. You actually have to do something else to break it apart further. And then finally, the melting point is going to be specific temperature. Why? Because in a pure substance, all the particles are the same. And that means all of those particles are going to have the same properties, including what the melting temperature is going to be. Now, looking at mixtures a little bit further, and again, this is something you've probably seen before, but we can separate mixtures into two different categories again. So we have what are called heterogeneous mixtures and homogeneous mixtures. So in a heterogeneous mixture, we will sometimes refer to these as what are called the mechanical mixtures. These are composed of two or more substances, and we can actually see the different parts. So for example, if I use again the example of dirt and rocks and sand and just like a scoop full of stuff you've taken out of the dirt in your yard, right? If you were to look at it, you will actually be able to see the different particle types in it. Right? It's very easy to see that it is a mixture of different items. Whereas with a homogeneous mixture, we will refer to these as what are called solutions. And again, it's going to be composed of two or more substances, but you can't see the different parts. And the easiest one to think of for this is, for example, taking salt and putting it in water. And I think we've all seen this done before, or sugar into water. You take sugar or salt, you put it into water, you mix it up, and the sugar or salt disappears. It hasn't gone anywhere. It's still in the water. It's just been it's been dissolved into solution. So what you would find if you were to look at it with, technology that we still don't even have at this point, to look at it smaller and smaller and smaller and smaller, you would see water particles, and you would also see salt or sugar particles. But if you were to just look at it with the naked eye, if you were to just look at that glass with your eyes, you can't see that there is salt or sugar dissolved into it. It just looks like water. So you can only see one thing. That's what's called a homogeneous mixture, right? As far as the pure substances go, and again, remember that pure substances have a constant composition. It doesn't matter where you look in the substance, all the particles look the same. But those particles can be composed of a single type of particle, or they could be composed of multiple different particles attached together. And that's the difference between what are called elements and compounds. And elements and compounds is what we are going to be focusing on for the rest of this course. So an element is a basic building block of matter. They are the simplest form of matter, right? Compounds, on the other hand, are made up of two or more elements. And specifically, they are in a constant proportion. In other words, in every particle, you will have, for example, two of one thing and one of another attached together. Now, this probably doesn't make a whole lot of sense to you yet, because we haven't really gotten into what an element is. All I've said is that an element is a basic building block of matter, and that really doesn't mean anything to you. So that's what we're going to focus on from here on in.